like it did earlier. Okay, so pulling all of our formulas together. Throughout this unit, we've so far covered 6-ish formulas. Technically, there was a 7th, but it's the exact same as one of the other ones. So, starting with arithmetic. So we had arithmetic sequences. We had a couple of different formulas for that, but we've only learned one so far. We've learned the explicit formula. Explicit formula for arithmetic goes a sub n is equal to a sub 1 plus n minus 1 times d. We will also be learning the recursive formula. So I'm just going to leave a spot for that one. We haven't talked about it yet. Now to go with our arithmetic sequences, we also have arithmetic series. Specifically, we have series equations for partial sums. Why is it a partial sum again? Because sequences are infinite in length, so we're only adding up part of them, so far anyway. There are two different formulas that we have for arithmetic series. They both start S sub n is equal to n over 2, a sub 1 plus a sub n. And the second one goes S sub n equals n over 2, 2a sub 1 plus n minus 1 times d. Now, we also have geometric sequences in series. Starting with the geometric sequences, we have the explicit formula. Which is a sub n is equal to a sub 1 times r to the power of n minus 1. We will also have the recursive formula, eventually. To go with the sequences, we also have the series. Again, we're talking about partial sums right now because we haven't yet started adding up entire sequences. That'll be next week, Tuesday specifically. So for geometric series, we have S sub n is equal to a sub 1 and in parentheses 1 minus r to the power of n over 1 minus r. Now, in all technicality, the book gives this formula as S sub n is equal to a sub 1 minus a sub 1 times r to the nth all over 1 minus r. It's the exact same formula. The only difference is I have the version of it where a sub 1 is factored out. I write this version because you need to recognize that it's still a geometric series formula. And the last formula that we have for now is S sub n is equal to a sub 1 minus a sub n times r all over 1 minus r. Yes, sir.
When doing whatever that word is, series ones, how do you know which formula to use?
What information do you have going into it? It's no different than when working with the geometric series formulas. It's what information do you have? The arithmetic series both formulas require n, both formulas require a sub 1. One of them requires a sub n, one of them requires d. Do you have a sub n? Use that one. Do you have d? Use that one. If you are trying to work backwards, where you're given a sum and you're trying to solve for some variable, you only want one thing to be unknown, whatever variable you're solving for. If you're solving for a sub 1, either of them could work. You just need a sub n or d. If you're trying to solve for a sub n, the top one. If you're trying to solve for d, the bottom one. There's not a time where one works and the other one doesn't to get you the same value. The only difference is what information do you have going into it. If you have enough information to use either of them, then you just got to make a choice. Now, one of the things as we work with these formulas, one of the things you're going to be expected to do is be expected to recognize which formula goes with what. Now that means you have to be able to differentiate between the sequence and the series formulas, for example. How can you tell the difference between a sequence formula and a series formula? We've talked about that. A series is adding, but I'm talking about the actual formulas themselves. S sub n versus A sub n. S sub n is series. A sub n is sequence. You're also going to have to be able to differentiate between which ones work for arithmetic and which ones work for geometric. I want you to take a close look at the geometric ones. What do they all have in common? I'm talking all three of these. R. Every single geometric formula has R. Every single one. Most of the arithmetic have D. That one doesn't. But every single geometric one has R. So to determine if it's arithmetic or a geometric equation, you look and see, is there an R involved? If there is, it's geometric. If there's not, it's arithmetic. Now, one of the things that I noticed over the last couple days that was kind of, I feel like, tripping some people up is kind of mixing in the word problems with everything else. Just because we didn't explicitly practice the word problems. And so yesterday, I pulled a bit of an audible. I changed up yesterday's assignment, which you may or may not have noticed. Because I pulled out all the word problems from it. Today we're talking word problems. But I got a note sheet for you.
I got you.
Okay, now, hey y'all. Hey y'all. Some extras went down. Now, when it comes to our word problems for chapter 10, there is a very significant difference between the chapter 10 word problems and the chapter 8 word problems in respect to the fact that in chapter 8, when we came across word problems, we had to know the formula that went with that kind of word problem. Now, don't get me wrong, you have to do that for this too, but those formulas were explicit to word problems. They had nothing to do with any of the non-word problems. Every formula that you use for a chapter 10 word problem is a formula we've already used. There's not some new formula that we have to figure out. It's just identifying the exact same things that I've been telling you that when I give you a problem, you have to identify anyway. You have to identify, is it arithmetic or is it geometric? Is it a sequence or is it a series? And then the additional thing for word problems is you have to identify where the variables are coming out in the problem. Hint, the variables are coming out as numbers. I know. mind-blowing. So, I'm going to move my formula sheet to the side. I'm not going to put it away. I want that. That's my friend today. Okay. So, starting off, looking at that first problem. Rectangular tables are placed together along the short edges as shown in the diagram. Write an equation for the number of people who could be seated around n tables arranged in this manner. Now, when they put one table out there, that's this one, how many people are seated?
6.
When they put 2 tables out there, how many people are seated?
10.
3 tables?
14.
Say it again.
Arithmetic.
This is arithmetic. How did he know that? Adding 4 every single time. So it's arithmetic. Adding 4 every single time means what? D is equal to 4. What's another important variable that shows up in nearly every sequence and series? And by nearly, I mean everyone. A sub 1 is? 6. Okay, now, it's arithmetic. Is it a sequence or is it a series?
Series.
Write an equation for the nth term. When did we write equations for nth terms?
Sequences.
Now, it doesn't say nth term. It says for the number of people, technically. But the number of people at a table is the numbers in the sequence. So it is a sequence. To write an equation, when writing an equation, some things stay variables. What things stay variables when writing an equation? A sub n and n. So, there's my arithmetic sequence general formula. I'm told a sub n stays a sub n. A sub 1 we found to be 6. N I was told stays n. D is 4. Do I leave an arithmetic sequence equation like that? No, I distribute, I combine like terms. 6 plus 4n minus 4 gives me a sub n is equal to 4n plus 2. Does that really feel any different than what we've been doing for the most part? It's a little bit different. It is a word problem, but it's not that much different. Some of them are going to feel more different than others, but many of them are very, very similar. It's why I hadn't been explicitly doing word problems before. Next one says you save $500, or you want to save $500 for a new tablet. You begin saving a penny on the first day, and you save an additional penny for each day after that. How much money will you have saved after 100 days? Okay. Not a whole lot of numbers in here. There's a goal as a number. That's going to be important later. We're told on the first day. If it's telling me about the first day, what is it telling me about? A sub 1. A sub 1 is? 1. 1 what? Penny. Now we are told that we save 1 penny on the first day and an additional penny the day after that. What's that mean on the second day? What's that mean on the third day? 4, 5, 6, 7, 8. We get the pattern? Okay. Now I have it written as a sequence. If I'm looking for how much money I will have saved after 100 days, when you do this, you have to ask yourself, if it's not obviously a sequence or a series, the way that you determine is, do I care about one number in my list, or do I care about what happened to get to that list, the sum or the total of them? So 100 days. This is day 1, this is day 2, this is day 3, etc., right? So the number of days is the variable n. So n is 100 from this. Do I care about the 100th day or about the total of the 100 days? The total. The amount of money you saved is the total of those 100 days. So this is arithmetic or geometric? Arithmetic series. Why was it arithmetic?
Because you're adding one.
Adding 1 every day, so D is 1. Wait a second. The first 100 days, I'm adding the first 100 numbers. Didn't we do this already?
Yes.
We did this as the warm-up on the day that we introduced arithmetic series. It's 50-50. Now, 5,050 what's? Pennies. If someone asks how much money have you saved and you answer them 5,050 pennies, aren't they giving you a weird look? How would you realistically answer this problem? $50.50, because there's 100 pennies in dollar. Now, granted, if you answered a question as 5,050 pennies on a test or on a quiz, would I get angry? No, because you're correct. Would I give you a weird look? Yes. Yes, I would. You won't be here as I'm grading it, but internally, I will be picturing your face and giving it a weird look. Like, why? Okay, but anyway. So, we already did the math for this one. So I'm just going to write that down. Determine how many days it will take for you to save $500. Am I still working with this series? Is the amount of money you're saving the total of the amount or an individual saved today? It's a total amount. You don't talk about, I saved $5 on this day if your goal is to save $500. You talk about your total. So we are still working with a series, and that is something you have to pay attention to. Sometimes problems will switch back and forth between working with a sequence and working with a series. So you have to think about the context of the problem. This one is still talking about an arithmetic series. It's never going to change back and forth from arithmetic to geometric. That'd be weird. But it could change back and forth from sequence to series depending upon the question they're asking. How long does it take you to save $500? How many days is the question? What are you trying to solve for? N. To save $500. That is the total you want to save. That is S sub n. Now, I'm going to tell you right now, I went through and started to do this problem with first hour, and I realized something I missed when I made this note sheet. I've never done this note sheet. I've never done this worksheet before. I noticed that I accidentally made a problem that in order to solve it, you're going to have to do the quadratic formula. I'm not going to make you do the quadratic formula in chapter 10. And on top of that, generally speaking, my goal of today, of the notes for today, is just to get you to be able to set up the equations in order to solve them. So for the notes today, note I said for notes, I did not say for the assignment. The assignment I expect you to solve. But for the notes, we're going to do more set it up, and then I'll write, then solve. We okay with that? Okay, now let's finish setting up this problem, and then we're going to move on. Now, arithmetic series formulas. I have 2 of them. Do I have an S sub n? Sweet. Do I have an n? No, but that's what I'm looking for, so that's perfectly fine. Do I have an a sub 1?
Yes.
Do I have an a sub n? No. I currently do not have an a sub n. I do not know how much I am solving on the nth day, and I can't find it using the sequence formula because I don't know what n is. Do I know a d?
Yes.
So, I'm going to use the second formula here. Second formula starts S sub n, but I'm not writing S sub n, I'm writing 500. equals n over 2. I'm writing n over 2. Parentheses, 2 times a sub 1. 2 times 1 plus n minus 1. N minus 1 times d. 1. Dot, 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 then solve. Yes.
How can we like mix dollars and cents in an equation? Because won't we have to make since the d's and
I forgot something. Yes, you're 100% right. Can we mix dollars and cents and have it make sense? S of n is not 500. There are 100 pennies per every dollar. Multiply by that. 50,000. My bad. I got distracted by reminding myself to tell you that we're not going to do quadratic equations, and I got distracted changing that to cents. Good catch, Mason. Thank you. You're not often going to have to convert. I'm not going to say never, but it's not typical. Anyway. Moving on to the next problem. You share a link for a movie trailer in a chat. 3 of your friends repost the link, then 3 of each of their friends repost the link, and so on. How many people posted the link on the 8th share? Okay. So, starts with you sharing the link, 3 friends sharing it, and 3 friends share of each of their friends sharing it after that. So, it started with you. How many people are you? I hope you're only one person. Each, that is, to be clear. The next share, 3 new people shared it. After that, 9 people, because each of those 3 shared it to 3, and 3 times 3 is 9. Etc. Now, writing this out is not always going to be easy or always to your benefit, but if you can, it can help you see where you're going. Arithmetic or geometric? Why? Multiplying by 3 from term to term, that's a geometric thing. Now the question asks, how many people posted the link on the 8th share? First off, the 8th share is telling you what variable? N. If it's talking about the 8th share, does it want the total or does it want just that specific term? Just that specific term, because it's referring specifically to the 8th. It didn't say after 8 shares, it said on the 8th share. So this is a sequence. Formula for a geometric sequence is a sub n equals a sub 1 times r to the power of n minus 1. We already established what n was. A sub 1 is 1, r is 3. So the formula would look like a sub n, which is what we're solving for, equals 1 times 3 to the power of 8 minus 1, or 7. Then solve. Could I have just as easily typed it into my calculator right now? Absolutely. But remember, our goal during the notes is just to set it up.
do you have the answer?
348 or something like that?
I got 2,000.
Yeah, 2,187. That's the next answer. Is almost.
I must mix up the answers. Yeah, I have them somewhere. $2,187. People, You should put units on word problems, by the way. People. This page is the only one that I actually had the answers for, though, so after that I won't have an answer. Okay, the second part of the question asks you to find the total number of people who reposted it after the 6th round. Now, they changed some things. Can they change that it's geometric?
No.
Not without completely reestablishing how the pattern works, anyway. They did change, now it's the 6th round, so they changed n to become 6. And now they said a special word. Total. Total, or sum, or all together. All are indicating that we are working with a series. Now we've got the geometric series. The geometric series, since we are looking for the total, we're looking for the S sub n, equals. Did a sub 1 change? Did r change? No. And I have n, so I would use the first geometric series formula. It would look like this. You'd get 364 people. But the key thing here is we set up the formula, then we solve. Next. Domestic bees make their honeycomb by starting with a single hexagonal cell, then forming ring after ring of hexagonal cells around that initial cell as shown. The first ring contains 6 cells, the second contains 12, the third contains 18, etc. Arithmetic or geometric?
Arithmetic.
What are you noticing? Adding 6. They gave you the first few numbers in the list. You'll notice that the pattern did not include the initial cell. Sometimes that happens. But yes, it was adding 6, making it arithmetic. Write an equation for the number of cells in the nth ring. In the nth ring, if I'm writing an equation for the nth term, the first one's a sequence. When I'm writing an equation, which things stay variables? A sub n and n. So it would go a sub n equals, what's a sub 1? 6. The first term is 6. Plus n, I was told, stays a variable, times d is also 6, because it's adding 6 every single time. Would we leave an arithmetic sequence equation like that? No. We would simplify this down. If you're curious, it'd be a sub n is equal to 6n. How many cells are in the 10th ring of the comb? Specific ring or all the rings? Specific ring, 10th ring. That 10th is telling me n. Specific ring means it's the sequence or series? Sequence. Specifically, don't I already have a formula for this? So I would just do what with the 10? Plug it in and multiply it by 6. Could you probably do that in your head right now without me having to actually do anything special?
Yeah.
How many cells are there?
60.
If you already have the sequence formula, and I ask you a question in regards to the sequence, plug it in. How many cells are in the honeycomb after the 9th ring has formed? This time it's in the honeycomb. Is the honeycomb a ring or the entire thing? entire thing. So this one is a series. It's still arithmetic, but it's an arithmetic series. The ninth ring is telling me n is equal to 9. A sub 1 is still 6. D is still 6. Do I know a sub n? No. Could I easily find it on this one? I already got a formula. This tells me the a sub n. It'd probably be easier to do that formula, but I could do the second formula if I wanted. Second formula, I'm looking for the sum, so s sub n is equal to n over 2, 2 times a sub 1, plus n minus 1 times d. Now this would give me the sum of the rings. What does the hint remind you of? Don't forget to add the initial cell. The initial cell needs to add what to my sum? 1. Then solve. I don't know what the answer to that is. I haven't done the math. A Sierpinski's carpet is a fractal created using squares. The process involves removing smaller squares from larger squares. First, you take a square and you divide it into 9 parts, 9 congruent squares. Then you remove the center square. In order for it to be a fractal, you repeat this process over and over and over again. It's a very specific type of fractal. A fractal is those funny looking things that have that repetition. And again, it's called Sierpinski's carpet when it's the squares. First one, question, which, by the way, the notation is not clear. This is not the word and, it is a sub n. Same over here, a sub n. Let a sub n be the number of squares removed at the nth stage. Write an equation for a sub n. So we're talking first the number of squares removed. In stage 1, how many squares were removed? 1. In stage 2, how many squares were removed? 8. 1, 2, 3, 4, 5, 6, 7, 8. In stage 3, it's kind of hard to see, but they're tiny and they're there. Nope. 64. 64 squares were removed. Arithmetic or geometric? What's happening? It's multiplying by 8, so it is geometric indeed. This first question's asking for an equation for a sub n. Is that a sequence or a series thing? It's a sequence thing. In order to write the equation for a geometric sequence, I need a sub 1. 1. I need r. 8. A sub n equals a sub 1 times r to the power of n minus 1. Do I typically simplify a geometric sequence equation? No. This one, can I? Yeah, because does 1 times anything do anything? No, so I don't really need the 1 on this one. If you leave it like this, that's perfectly fine. Part B says find the total number of squares removed through stage 8. Total? Series. Oh, why did I change color? What am I doing? It's the same question. Through stage 8? It's telling me n. So, geometric series formulas. I got a couple of them. Which one am I going to use?
First one.
The first one, because I do not know a sub n. Could I find a sub n? Yeah, I got a formula for it. Do I want to? Not really. I'm looking for the sum, so S sub n is S sub n. A sub 1 we said was 1. Times 1 minus r was 8. To the power of n was 8. Over 1 minus r. So 1 minus 8. I make sure if I'm going to type something like this into my calculator, what am I doing to it?
Added parentheses.
Putting parentheses around the denominator specifically. Is a big number. The fractals tend to do things very quickly. Okay. Now, there are more questions that go with this one. Let B sub n, that says B sub n. I know it's not the clearest to see, but it does. B sub n. B sub n. With a random backslash here. Okay, let B sub n be the remaining area of the original square after the nth stage. Write an equation. We're writing an equation. We're working with a sequence or series. Generally, it's a sequence. Unless they say write an equation for the sum, which they don't generally do. Now, we're talking about a different problem here. We're not talking about the 1, 8, 64 anymore. This is one of the few times where we could change from arithmetic or geometric because they're completely redefining the problem. So it's talking about the remaining area. Now, if I go back to the description, it says, assume that each side of the initial square is 1 unit long. So they're telling us this here is 1, that there is 1, which means the initial square had an area of 1, because 1 times 1 is 1. What about stage 1?
1 minus.
We removed 1 square, left 8 squares out of a total of 9 squares. 8 ninths is the first one. Now in the next one, they took out those tiny little squares out of the 8 remaining squares, leaving us with
64 ninths.
8 ninths of what we had. 8 ninths of what we had is
64 ninths.
64 ninths. In other words, oh no, not 64 ninths, 64 81sts. Essentially, every single time they're taking away 1 ninth, leaving us with 8 ninths of what remained, they're multiplying by 8 ninths every time. Is it still geometric? Yes. I don't remember what the top is.
512.
Thank you. Okay, so it's still a geometric sequence, but it's a different geometric sequence. This time, a sub 1 is 8 ninths. R also happens to be 8 ninths. Not a sub n. B sub n. They messed with me. They changed it to a b. Equals a sub 1. B sub 1. I guess it is b times r to the power of n minus 1. Now, for this to be a correct equation, what is necessary? Parentheses around? The 8 ninths specifically. The second 8 ninths. The first one, it's not the end of the world. Okay, part B. Then find the remaining area of the original square after stage 12. They gave me another n. The remaining area of the original. Sequence or series? The this one breaks the mold. Occasionally, a problem will not fit what you would typically think it would. And the reason it does that is if the sequence already references the total of what was there. 8/9 was the total remaining. 64/81 was the total remaining of what was already remaining. This is the remaining of the previous total. Generally, it doesn't happen very often, but this one actually breaks the mold. This one actually is a geometric sequence again. Are you going to see this very often? No, but I wanted you to at least see it once. And it's because the list represents the total. If the list represents the total already, then it can be a sequence, even though it looks like it should be a series. Again, you're not going to see it very often, but it can happen. Okay, we got one more page that we need to connect about, and this page is going to have something in common between these problems, but it gets approached in a slightly different way. Each of these problems has a percentage. How do you find 30% of something? You multiply by 0.3, or you put 30 over 100 and multiply by that. In either case, you are multiplying by something. Every single time you see a percentage problem, it's going to be a geometric one. But what's going to differ is how those percentages affect these problems. Because when it comes to working with percentages, percentages happen in various different ways. For example, going with something very, very basic. The number 10. What is 30% of 10? 3. What is 30% off 10? 7. I gotta rate this differently. What is 10 increased by 30%? 13. Percentages come in 3 forms. There's percent of, percent off, and percent increase. Percent of is the straight up most basic problem. You multiply it by the 0.3. Percent off means you need to take that percentage away from the 100% that was there. 30% out of 100 is, or off of 100 is 70% left. And you do that percentage, 70% of 10 is 7. And a percent increase means you keep the original 100% and then tack on the 30%. In other words, you find 130% of 10 and you get 13. Each of those is going to affect what you multiply by, so you have to pay close attention to how it references the percentage. The first problem says, 1 minute after it is released, a gas-filled balloon has risen 100 feet. Each succeeding minute, the balloon rises only 50% as far as it rose in the previous minute. How far will it rise in 5 minutes? Now we know it's geometric. We're going to come back to the percentage piece. Is it a sequence or is it a series? The question is how far it will rise in 5 minutes. Total of 5 minutes or the 5th minute? Total of 5 minutes is how that's interpreted. Therefore, it is a series. A sub 1 is 100. 5 minutes is telling me n. The percentage is always going to be the r. But, again, we have to interpret. Is it a percent of, a percent off, or a percent increase? It rises 50% as far as the previous one. It's an of. It rises 50% of the previous one. If it goes 100 the first time, the second time it goes 50. Not. Only 50% as far. Only 50% of. So R is 0.5. For it to be a percent increase or a percent decrease, or percent of, or sorry, off or increase, off is technically a percent decrease. It will have a specific word indicating that it's increasing by that percent or decreasing by that percent. It didn't say it increased 50% more. It didn't say anything like taking 50% away from it. Now, in all honesty, could a 50% off and a 50% of do the same thing? Yeah, so this one's a little bit wishy-washy on that. Either way, R is going to be 0.5 in this one. So, our formula would look like this. Again, then solve. I don't know the answer off the top of my head. A hatchery raises trout for creek restocking. There are 6,400 unhatched eggs at first. Each day, this number decreases by 25% as the eggs hatch. How long will it be until 2,025 unhatched eggs remain? We know it's geometric. We see a percentage. We know the 6,400. That's the first amount, so that's A sub 1. Each day it decreases by 25%. If it decreases by 25%, is that a percent of, off, or increase? Off, which means R is 0.75 because you need the 100% minus the 25%. You get 75%. Therefore, R is 0.75. Because 75% is divided by 100 is 0.75. How long will it be? We're looking for N. It's 2025 is going to be telling us a little bit about if it's a sequence or if it's a series. Percentage problems are ones that tend to include the total in them already. This is a sequence because the percentage already takes into the account that total amount that's left in there. This is a sequence. That is an A sub n. The percentage problems are going to be the common problems that will have it be a sequence. Percentage problems as a series don't make sense. At least not very often. There's going to be some cases. This one, since it was talking about a percent off, is not going to be that. A percent of problem, those ones can be series. A percent off, a percent increase, already take care of that. Okay, last one. Electric bill increases by 5%. What kind of percentage problem is it? Percent increase. 100% plus 5%. 105%. In other words, R is going to be 1.05. If you started paying $2,500, you started A sub 1. For electricity 6 years ago, that's N. How much will you pay each year now? Individual year. Sequence. You're looking for an A sub N. How much did you pay over the last 6 years? That is a series. I think I explained when it shows up as a sequence terribly. And I'm recognizing that. If the problem is set up where it's automatically talking about what's left there, the remaining kind of idea, this carpet did that, this one did that, then the sequence already takes into account the total. That's the best way I have to describe it. I need to rethink, and if I come up with a better way to describe it, I will come back to you with that. I realize I just kind of fell on my face on that one. But yes, if it's giving you a list where it's already referring to what's left over, that's going to be when the sequence already takes into account the total. If it's not talking about what's remaining, then sequence and series breaks down the same way we've already been doing it on 90% of the problems. That kind of makes sense. I feel like I'm still a little iffy. I'll find a better way to explain it. Okay, but we are going to stop right there.